All right, welcome back to another episode. In our previous episode, we were pretty close to having a finished calculator app. We had made it so that you could type in numbers. They would go ahead and append just like you'd expect. You can do decimal places, and it adds reasonable restrictions like only up to 9 things typed and only 1 decimal place allowed. Now in this one, we're going to go ahead and we're going to wire up our remaining 8 buttons. So our clear, plus, minus, percent, and all our arithmetic buttons. Now, by the end of this episode, we're going to have a fully functioning calculator app. So this will actually be the final functional lesson that we have. I'm going to do one additional lesson where we're going to do extra credit. We're going to go through and update some styling. We're going to do some advanced stuff, and I'm going to move a lot faster on that lesson. So for people that are pure beginners and aren't interested in going that extra little bit, this can be your last lesson. One other thing to note is in between this lesson and last lesson, I actually injured my hand, and so I'm typing really slowly. And so I went ahead and I pre-typed everything. Otherwise, this episode would be an hour long. And so I'm going to walk you through line by line as I re-add the lines of code. I just want to give you a heads up that that's why the format's a little different. So what we're going to do first is we're going to create what's called a model for each of our arithmetic operations. And so what we're going to do is we're going to introduce what's called an enumeration. Now the word enumeration literally means to list out all possible cases. And so for this, we're going to enumerate all of the arithmetic operators that our app can do. So our arithmetic operators in this case are going to be add, subtract, multiply, divide, and what I'm calling resolve. And resolve's a little weird, and I'll explain it later, so just trust me for now when we use it, but it's basically equal to what the equal button does, is it's just going to resolve whatever we're working on. But I'll explain it as we get further in the lesson, just take it on faith for now. All right, so let's come down here. Now the first thing we want to do is we want our view controller to keep track of what the user was typing. And now we already have user input, which keeps track of the numbers that the user was typing, but we're going to add arithmetic operator as a variable on our view controller. And we're going to start it as resolve. And again, I'll explain that in a little bit later, but for now, just trust that resolve is the correct thing. And we're going to have this variable so that as the user types arithmetic operators, we can get the updated one. So the other thing we need is mathematical operations need 2 numbers. So currently user input is what the user is currently typing. And so if you were going to do like 5 plus 5, for example, you need that first number, the first 5, to be saved somewhere. And that's what first number is going to represent, where user input is going to represent what they're currently typing. So yeah, if 2 plus 10, first number would be 2, user input is going to be the 10. So if we go ahead and run, you'll notice nothing's actually changed here, but this just confirms that we've typed everything correctly. If it's not working for you at this point, go ahead and rewind, check your syntax, make sure it looks exactly the same. And then as soon as it's working and it's running, let's move on. Now, if we scroll down here to the end of the file where we have our add, subtract, multiply, divide, equals buttons, we're going to go ahead and we're going to add the functionality for each and every one of them one at a time, but they're all basically the same. So in this case, for the add button, all we want it to do is to perform the add operator. So you tap that button, do the add. We're going to create a function called the perform operator function, and then we're going to pass it the add enumeration. That's just from our enumeration at the top of the file. And you can see, if you peek and add, each and every one of these does the same thing. It just performs the operator that we pass to it. But let's scroll down. Let's see what perform operator actually does. All right, so the perform operator function might look a little intimidating, but it's pretty easy actually. If you look at how we actually perform an operation, when you go to perform an operator, what we're actually saying is, hey, the user just pressed the button for an operator. And so what actually happens is it needs to make sure that there's user input, and it also needs to perform the operator previous. Now, the reason why this makes sense, the way you can kind of think about it is, if I've got my calculator open, and you can try this right now, and I press 5 plus 2, nothing happens. But if I press plus again, so 5 plus 2 plus, as if I'm going to type something else, then it resolves the 5 plus 2. So in this case, what we're going to do here is, first thing is we check to see if the user input can be converted into a number. And that's where we introduce this if-let syntax. It basically says, conversion from a string to a double could fail. And in our case, it's never going to, but let's say our code had a bug, or let's say this is a completely different app and you just passed some random string full of letters into this conversion, it would fail. So what if-let does is it says, don't go inside and do this code unless you have successfully converted self.userInput into a double and saved it into this new user number variable. And then else is, well, if that fails, then we know that in our case, that it was just blank user input. And so what we want to do is go ahead and save the arithmetic operator because it's the first one that they've typed. So let's go back to this top one, the case that actually matters here. The user has typed in a number. So we've got a string. We're going to convert it into a double, which is our number. And then we're going to pass it to this doMath function. Now, the reason why we're going to have this doMath function is we have an enumeration that spells out all the kind of math we want to be able to do. We actually just need to be able to do the math the way we did in, I think it was our second lesson. And so in this case, we're going to create a doMath function that takes the first number and the second number. So in this case, like 5 plus 1, it would take those two numbers, and then it would perform the plus operation on them. So you can see in our parameter list, it passes in self.firstNumber, which is the variable we created to hold the first number in our mathematical operation. And it takes in the second user number, which is the one that we just converted from our user number. And this is the part where it might get tricky, and we talked about this just a second ago. It doesn't perform the operation the user just typed. It performs the previous one. So if you're doing 5 plus 5, that doesn't immediately resolve. It only resolves once you press the next operator. So if you did 5 plus 5 plus, then it would squish the two 5s and the plus operator that it did the first time around into a 10. And so that's exactly what this does. It passes the previously saved arithmetic operator. All right, so that was a lot to just say it does 5 plus 5 plus, and then it performs the plus 5, the first plus 5. Then what it does is it takes that new number and it saves it to our first number. So you can kind of think of this as if the user's typing some big old long thing, it is slowly squishing everything to the left. Actually, let's go ahead. We're going to spell it out so you can see. So in this case, the user pressed 5 plus 5 plus, and as soon as they hit that second plus, it would squish the 5 plus 5 into 10. And then the next line after this would be, well, if the user typed then plus 6 equals, it would squish the 10 plus 6 into 16. And then they press plus 2. And then if they did, plus 2 equals, then it would go ahead and squish over to 18. So you can see how it's slowly just pushing everything into our what we're calling our first number. It's just pushing everything to the left. So after we have performed an operator, that's what our first number is. It's our leftmost number. We're going to save our new number into our first number. We're going to clear out our user input, and we're going to update the text that we draw on our label. And then finally, we're going to save the arithmetic operator that the user just typed in. So I talked about above the resolve operator, how it didn't make a ton of sense. But if you look at it in terms of, all of these operators are kind of performing the thing that they did previously, when it's time for the resolve operator to be performed, all it does is it actually just pushes everything to the left. It doesn't actually do anything to the numbers. So that's why it's special. And you'll see this in a second here. So let's go ahead and create our doMath function. It has a first and a second number and our arithmetic operator. and we're going to introduce what's called a switch. Now, switch is kind of the same thing as just doing an if-else and just checking every possible case on an enumeration, but it's nice because we can pretty conveniently spell out all of the different cases that we've got. So in this case, we've got the add operator, and all it does is it just adds the first and second number. So if we said first number is 6, second number is 1, arithmetic is add, it would come to this switch, it would see add, and then it would return from this function first plus second, 6 plus 1. And that's what every single one of these does, is it just actually performs the math rather than what the enumeration did, which gave us a way of saving which math button they had pressed. So let's go ahead and take a look at this. So I press 5 plus 5, and you can see, of course, it doesn't immediately resolve until we press plus again, as if we were going to type another number, and then it resolves, and then we can press 6 plus 2 plus, and you can see the number just keeps growing. But it's kind of doing this thing where each time you press it, it resolves the previous operation and then pushes that onto our first number. And if you want to see that in even more detail, what we're going to do here is we're going to click in this left column over here, and we're going to create what's called a breakpoint. Now, when you want to get rid of these, you just drag them away. But what this does is it will actually freeze our code when it gets to that point. So if I press 5 plus, you can see that as soon as I press the plus button, it zooms us right here to this code, and it actually lets us see and step through what's happening. So if we come down here, we can actually see the arithmetic operator is plus or is add. And you can even see that if I hover over the variable, it actually knows what it is because it has paused as the app is running, which is pretty awesome. So we can even go look and we can see self.userinput is the string 5. And if I step over here, you can see that the user number has been successfully converted to 5, just the number 5, so that we can now do math on it. You can again hover and you can see that. Step again and you can see that the result of doing math is maybe not exactly what you expected, but this further illustrates the point that it's not doing the add operator like you might think. It's doing the resolve operator, which is what we started the app as the first operator. And so what the result of that is since we pressed 5 plus, it just makes it so that the first number is 5. Because you have to get the first number somehow. And so resolve, like I said, is just a way of taking what the user is typing and pushing it to the left in our operation here, making it our first number. So then after it performs the operation, you can see it clears out our user input, and you can see that down below. We update the text in our label, and we update the arithmetic operator that we're saving. So let's go ahead and drag away this breakpoint. We don't need it. That lets you see step by step in real running code how this is working. And you can do this for any piece of code. That's a really great way to understand and find bugs and figure out what your code is doing. So let's come up here. Let's do this for subtract. Now subtract is going to be exactly the same, calls the same exact functions here. The only difference is when it gets to this switch, it's going to come down, and instead of doing add, it's going to return first minus second. It's going to do the subtract operator. So we can do 5 minus 2 minus, which results in 3, 1 minus, which results in 2, minus 2, which results in 0. So we've got a fully functioning add and subtract operator just by reusing the same code. So let's go ahead and add multiply and divide here. Because you can see multiply, literally the same thing. There's nothing special about it, just plus, minus, multiply. And then the one that's going to be a little special is divide. And you may have learned this in your math class, but dividing by 0 is just not a thing. In fact, if you punch that into your calculator today, you'll see that most calculators just print error or not allowed or something like that. And this is one of those cases that we could go ahead and handle that, and we could make a special case. We're not going to do that. There's a lot of these edge cases in the calculator app that we're just not going to build for the sake of time. So in this case, we're just going to say, look, if the second number that was typed in was a 0, don't divide by 0. Just return whatever number we currently have. We're just going to stick with that because, you know, we actually don't care. We really don't care about handling this case. And it's just an easy way of getting out of trying to deal with that. But if what they did type was division by an actual number that's not 0, then what we're going to do is we're going to return first divided by second. So this is just a little safety check to make sure that you don't get in trouble dividing by 0. So again, here's our resolve. This is the last one we need to think about as well. We can go ahead and make our equals button work while we're at it. In order to make it so that it just pushes whatever the user has typed in, which would be second number, into our first number, all we're going to do is when we perform the resolve operator, that just means hand back the second number. And so in this case, the app starts with the first number being 0, and the operator being resolve. So when the user presses the 5 button, it will push the 5 in place of the 0. So that's how we're going to implement our equals button. In fact, we should probably go ahead. Let's scroll back up here and let's add the call here to our function so that our equal button works. Again, just calls the exact same functions that we've already been writing, but it uses resolve instead of one of the other arithmetic options. And so we do 5 plus 5 equals 10. Divide that by 3, and you get 3.33. And we go ahead and multiply it by 100, and that turns it into 333.33. So now we have 3 buttons left. That's pretty close to finished. So here's another case that we're not going to handle, and maybe this is some homework that you can take home and try to figure out. In the calculator app, if you press 5 plus 1 equals, it would just print out 6, which is good. That's what we want, and that's what our app currently does. But they have a special case where if you keep pressing the equals button, it will perform the same operation over and over and over again. So if you press 5 plus 6 equal, or 5 plus 1 equals, it'll print 6. And then you press equals again, it'll print 7. And you press equals again, it'll print 8, and so on. So this is something that you could figure out how to implement on your own. The other is printing out error when somebody tries to divide by 0. So maybe you want to figure out how to go ahead and add that kind of a functionality to your app. So there's just a few of these little what we call edge cases that we're not going to handle, but they're things that you can think about and you could add to make the app more complete yourself. All right, let's move on. We're going to go down here. We're going to add functionality for our clear button. Now the clear button is different from the arithmetic buttons, and it does something different depending on what state the user is currently in. So if the user is currently in the middle of typing something, pressing the clear button will remove what they're typing. But if the user has pressed equals, so if you did like 5 plus 5 equals 10 and then hit clear, it'll reset it as if you had just launched the app. So in this case, we're going to say if user input, they've typed more than 0 things, what we're going to do is we're going to clear their input and then we're going to update what we're showing in our label. So this is just a quick way of saying like, hey, has the user typed anything at all? Now, the else, so the otherwise here, so they haven't typed anything, that means that we need to reset the app as if we just started. So first number equals 0. The arithmetic operator is resolve, user input is empty, and then we're going to update the label, just like when we first start the app. All right, let's go ahead and run this so you can see the clear button in action. So if I press 5 plus 5 equals 10 and then clear it, that starts the app completely over. Whereas if I press 5 plus 5 and then change my mind, I can press clear and maybe change that to 5 plus 2, and that'll give me 7. All right, so that's the clear button working, pretty simple. Now we're going to jump over to the plus minus button. Now, plus minus button is the same, where it does something different depending on if the user is currently typing. So for plus minus, if the user is currently typing, it multiplies what they're typing by -1. Whereas if they're not typing anything, it multiplies the number that we have saved by -1. So you can actually see this in action here. So if I do like 5 and then hit plus minus, it changes it to -5. Or I can change it back. But if I did 5 plus and then 3, let's say, and I hit the plus minus, it changes just the 3 to negative. And so and you can see that by pressing equals, 5 plus a -3 is 2. So this is our way of handling, either inverting the user input or inverting the number that we have resolved our math to. Okay, now finally the % button. Now this one is weird. I had to Google what this button even did because it didn't make sense to me. But basically what it does is you either have the option of if the user has already finished, so like let's say they did 5 and then they hit the % button, that divides it by 100. So it would convert 5 into 0.05. But if you did something like 100 plus 5%, what that is saying in like user language would be 100 plus 5% of 100. So if the user is currently typing something, it converts that into a percentage of the first number that was being typed. So let's go ahead and look at this here. So you can see if we have user input and that first number that they've typed is not a 0, then what we do is we convert it, we get a new number out of the number that they've typed as a percentage of the first number. So that's just the way you do that mathematically, is first number times second number divided by 100. And then we save it to the user input, and there's implicitly a resolve. So this is another interesting thing the % button does, is it's as if you pressed the equals button when you do like 100 plus 5%. It's kind of weird, but that's what it does. Now the other option here is if we just have some user input, but the first number is actually something that's not 0. So in that case, it is you take the user input and you just divide it by 100. So in this case, the app just launched. That means that first number is 0 and user input is whatever I'm typing. So in that case, it would convert user input to, let's say I was typing 5, it would convert that to the number 5, and it would just update this new number here. It would just multiply this new number here to be 5 divided by 100, and then it would push that over to be our first number. So then we go ahead and we clear out our user input and we update the text at the top of the screen. All right, so those are our weird operators taken care of. And we can even test that they work the way we expect. So we can do 100 plus 5%, gives you 105 because 5% of 100 is 5. We can also do 5 and then hit %, and it just divides it by 100. And if you want, you can go ahead and throw some breakpoints in there and step through it yourself so you can kind of make sense of the math that's happening as you click these buttons. But anyway, that's it. If you can scroll around our file, you can see we've actually written quite a bit of code here to get a working calculator, and it looks really great. And if you're an actual beginner, like these lessons are targeted for, congratulations, you have a really full functioning app that you can show off to people. Now, in the next lesson, we are going to do the extra credit. So we're going to move fast. We're not going to explain a lot, but we're going to go through and we're going to add an app icon. We're going to update our buttons to use some actual icons rather than just typing in the Unicode characters. We're going to do all sorts of just clean up things to make it look better and behave a little nicer. But we're not going to change any of the math. We're not going to change any of the actual functionality in terms of being able to function as a calculator app. So if you stop here, you are good to go. The next lesson is extra credit. That said, you've made it this far. Hopefully we see you in the extra credit. Thanks for watching.